See here, this is single phase half-wave rectifier for R load. When this thyristor is on, we will get the load current I0. Therefore, V0 is equal to I0 into R. So once it is short circuited, then only from here, from alpha onwards, it is short circuit. See, current is flowing from alpha onwards. Before firing angle, before you give firing pulse to thyristor, there will be open circuit voltage because thyristor is open. When thyristor is open, whatever the voltage we are having here, that voltage will appear as thyristor voltage. So what are the limits for output voltage? Only during, what are the limits? That means only from alpha to pi. Only during positive cycle, this thyristor is on. During negative cycle, the polarity is changed and thyristor is reverse biased. That's why there is no output voltage in the negative cycle. That's why only during half cycle only we can control the voltage. That is from alpha to pi, we are getting output voltage for resistive load. That's why taking the limits as, see the limits. V0 is equal to 1 by total time period. Limits are alpha to pi. Why 1 by total time? 1 by 2 pi. 2 pi means total time period of one cycle. 1 by total time period integral of alpha to pi. Input voltage is Vm sin omega t. This is the instantaneous voltage d omega. If we simplify that, we will get this form. This is average output voltage. For RMS voltage, we will take the squares on both sides. If square comes to this side, it will become square. Square of this Vm sin omega t. Vm sin omega t whole square. That is Vm square sin square omega t. I have derived this formula. I have shared the derivation also to you. If you simplify this, you will get this formula. This is the formula for average voltage. Average current is average voltage by R divided by R. Vm by 2 pi R 1 plus R. This is RMS voltage, RMS current. Next, power delivered in the load. Input power. This is the power in the output power. This is input power. Power factor is equal to output power by input power. We will get the formula. Okay. See, in all the power factor is independent of voltage and current. There is no voltage term and current term in the power factor. Otherwise, we can determine V naught R and Vs. We can determine power factor. Okay, power. This is the derivation for the single phase half-wave rectifier for R load. For RL load, due to presence of inductance, it cannot accept sudden changes of current. Therefore, after pi, your current is not coming to zero immediately. It will take some time to get to zero. Up to this point, you will get output voltage. There is beta. Beta is called extinction angle, the point where current extinguishes to zero. From here, draw one straight line in backward direction. So up to here, this is the output voltage. Wherever you are not getting output voltage, we will get the thyristor voltage. Okay, current zero అయింది, that's where thyristor is open, you will get output voltage like this, thyristor voltage. Now for RL load, what is the output voltage formula? See here, V0 is equal to 1 by 2 pi, alpha to beta. For R load, we have taken alpha to pi. For RL load, we will take alpha to beta. Okay, limits are alpha to beta. See here, output voltage. From the waveform, we'll get the limits. From alpha to beta, the limits. In a resistive load, alpha to pi only. But in RL load, alpha to beta. So see the page number. One minute. Page number 180. The formula is there. V0. 1 by 2 pi integral of alpha to beta Vm sin omega t d omega. With respect to omega t, we have to take the derivation. This is the formula for V0. This is the formula for I0. Similarly, RMS voltage. Next, single phase half-wave rectifier with RL load and freewheeling diode. With freewheeling diode. This is freewheeling diode. Here the limits are alpha to pi only. Why alpha to pi? Because after pi, freewheeling diode is on. When it is on, it is freewheeling diode is on, thyristor is open. Now load is short circuited with the freewheeling diode. Current freewheels through the your current is not coming to zero. See here. If load is short circuited with the freewheeling diode, Anything which is in parallel with the short circuit, this is also voltage is 0. Here short circuit voltage is 0. Any load in parallel with short circuit, this is also short circuit. In short circuit, your voltage is 0. That's why you are not getting the negative spike. Even though we are having RL load, due to presence of freewheeling diode, we will get output voltage only up to pi only. There is no negative spike. Why means load is short circuited at the freewheeling diode. Anything parallel with the short circuit, this is also short circuit. In short circuit, your voltage is 0. See in RL load previous case, in RL load, we are getting up to, when current 0, it will be up to beta. But here in the next case, in RL with freewheeling diode, your current is not 0 because load is short circuited. In short circuit, current will flow in the load, but voltage is 0. That's why there is no negative spike if you use freewheeling diode. Even though it is RL load, if you use freewheeling diode in parallel with this, your current will flow. From pi onwards, current is decreasing until you give firing pulse in the next cycle. So there is no negative spike. Therefore, limits are alpha to pi. Therefore, whatever the voltage you get for R load, the same output voltage you will get for RL load with freewheeling diode. Okay. See, V naught is equal to 1 by 2 pi. Same limits for R load and RL with freewheeling diode, alpha to pi. But only RL load, alpha to beta. Okay, Vm by 2 pi into 1 plus cos alpha. Okay. Next one is RLE load. For RLE load, if anode potential is greater than cathode potential, then only it is short circuit. See, up to this E value, battery voltage, it won't get into on state. After this battery voltage only, this thyristor will be on. Because when this input voltage is greater than battery voltage, then thyristor is on. Why? Anode potential should be greater than cathode potential. Therefore, after theta 1 only, you can give firing pulse. From theta 1 to theta 2, we can give firing pulse. Before this, battery voltage is there. In output, we are having battery. Even though current is 0, there is battery voltage in the output. So here the current is increasing when we give firing pulse alpha. Slowly up to pi it is increasing. After pi, current will decrease. This thyristor will conduct only during positive cycle. In negative cycle, it is reverse bias. So up to beta, up to this point, we will get output voltage. After this point, the thyristor is open, then I naught is 0. Even though I naught is 0, V naught is equal to battery voltage in the negative cycle until you give firing pulse in the next cycle here. Okay, this thing I have explained in the class. Just I am revising. So these are the questions in single phase. This is half wave rectifier. Now come to full wave rectifier, full wave bridge rectifier. Page number 189. So not 189, sorry. Page number, not 189, page number 192. Single phase full wave rectifier RLE load. Single phase full wave rectifier, at a time will get firing pulse to two thyristors. See, T1, T2 will give firing pulse during positive cycle. During negative cycle, T3, T4 will give firing. Because during positive cycle, T1, T2 are forward biased. We can give firing pulse to T1, T2 during positive. In negative cycle, this polarity is changed. Then T3, T4 will be on forward bias. They can give firing pulse to T3 and T4, T3 and T4. Then from negative cycle is also converted to positive cycle. See in output, this is input, this is out. Why negative cycle is converted to positive cycle? Can anyone tell? Why this negative cycle is converted into positive cycle in output voltage? Can anyone tell?
Because of a battery.
Not because of battery. See, when during positive cycle, this is plus minus. Current is flowing through T1, load, T2 like this. Now when T3, T4 are on, this polarity is changed. Now current is downward. In the input, current direction is changed. When T1, T2 on, current is in the upward direction. When T3, T4 on, current downward direction in the source. లోడ్ లో కరెంట్ డైరెక్షన్ చేంజ్ అయిందా? T1 T2 ఆన్ ఉన్నప్పుడు డౌన్వర్డ్ లో ఉంది. T3 T4 ఆన్ లో ఉన్నప్పుడు కూడా డౌన్వర్డ్ డైరెక్షన్. Direction in the load is not changed. Current direction in the load is not changed. In the input, current direction is changed. Source current. T1 T2 on ఉన్నప్పుడు current in the upward direction like this. T3 T4 on ఉన్నప్పుడు ఈ polarity change అయ్యి current downward direction లో flow అయ్యి T3 load. కానీ లోడ్ లో కరెంట్ డైరెక్షన్ చేంజ్ అవ్వట్లేదు. T1 T2 ఆన్ ఉన్నప్పుడు T1 from anode to cathode only current will flow. Downward direction. T2 like this. T3 T4 ఎప్పుడు ఆన్ అవుతాయి? ఈ polarity change negative cycle. During negative cycle here. Now current flows. This is negative, this is positive. Current direction is reversed in the source. But in the load, current direction is not changed. But in the load, current direction is not changed. See, that's why negative cycle is also converted to positive cycle. Again, during positive cycle, T1 T2 on. Negative cycle, T3 T4. T1 T2 you are giving firing pulse here. T3 T4 firing pulse. In the negative cycle you are giving firing pulse here. So from this point, take straight line. This will be the output voltage until you give firing pulse in the next cycle. Okay, is it clear? Negative cycle, why it is converted to positive cycle means current direction in the load will not change. Output is DC. See, this is DC. Input is AC. AC means positive negative cycle, but in the output there are only positive cycles. If you take average of this, take average, this will be the average. Okay, average output voltage. Now what is the formula for average output voltage? You see here, V0 is equal to 1 by 2 pi. Actually it is 1 by 2 pi. Why I am taking 1 by pi means two symmetric cycles are there here. 2 into 1 by 2 pi. What is the value of 2 into 1 by 2 pi? It is 1 by pi only. In half wave only one cycle you are getting in a period of 2 pi. But in full wave we are getting two symmetric cycles. That's why 2 multiplied by 1 by 2 pi. 2 is going to be cancelled. 2 into 1 by 2 pi. Integral of alpha to, see the limit, alpha to, this is pi, pi plus alpha. One cycle is alpha to, this is pi, pi plus alpha. Up to pi plus alpha you are getting output voltage. Alpha to pi plus alpha, your limits. It is not alpha to pi, it is alpha to pi plus alpha. Vm sin omega to do. This is the formula for full wave rectifier, 2 Vm by pi cos alpha. So these are the 5 questions which I have given here. 1 minute. So derive the waveform, draw the waveforms for single phase half wave rectifier for R load with derive the parameters. First one is R load, single phase half wave rectifier. Next RL load, single phase half wave rectifier with RL with freewheeling diode. Next question is single half wave rectifier for RLE load and derive the parameters. Next is single phase full bridge rectifier for RLE load and derive the parameters. For fourth question for RLE load, single phase half wave rectifier for RLE load, which derivation you have to note down the page number. I'm telling equation numbers also for fourth question. See, for fourth question, single phase half wave rectifier for RLE load, derivation I am telling. This is single phase half wave rectifier RLE load, page number 183. Page number 183 for fourth question. This waveform circuit diagram, waveform, and derivation is I'm only the equations whatever I'm telling you, note down this. Equation 6.18, note down. You have to write this equation 6.18. Equation 6.18. Next you have to write sorry. Okay, no problem. Equation 6.18. Next one is this equation, V0 equation. Number is not given here. V0 equation, write down. This equation and this equation. V0 equation and I0 equation. So below equation 6.20, one equation is there, V naught, I naught, then V naught is equal to E plus I naught into R. V naught is equal to E plus I naught into R. Equation 6, this one. So up to here, this is V naught equation. V naught is equal to E plus I naught R. Up to here you have to write. Okay. Then I naught R. I naught R is equal to this formula. Then output power in the load. This is the power in the load. Then power factor is equal to, this is output power. Power factor is equal to output power by input power. Power factor is equal to output power by input. Up to equation 6.25. Okay, up to equation 6.25. From where? From below 6.20. 6.20 to from below equation, not this, not 6.20. From this equation to 6.25 equation. These formulas we had tried. Then yesterday I have given next question problems. A single phase 230 volt 1 kilowatt heater. I had told yesterday this question. In this question, V naught R is equal to Vm by 2. What is Vm? Vm is equal to root 2 into Vs. Vs they have given 230. This formula is there. What is the, see the formula for single phase half wave rectifier for R load. Okay. Next question I have given this one 6.3. Example 6.3, RL load and RLE load. These two problems is 6.1 and 6.3. So yesterday I have shown this is the problem. Single phase to the 6.1 in your textbook. Problem number 7 is 6.3. 6.3. Okay. These are the 7 questions in the second unit. Okay. If you are hanged out in these 7 questions, you can ask me.